Those are the slides. Okay, well, thank you for the introduction. Ernesto, thank you so much for the invitation to be here. Can you hear me in the back? Excellent. I'm going to try to use this mic so that I can walk around. It's a little more comfortable. So it's really great to see all of you here. You know, everybody's time is very precious, so showing up and coming to this tonight, I really, really appreciate it. That means a lot. Tonight we are going to talk a little bit about data visualization in practice. And to get started, I'm going to tell you just a little bit about myself and how I got involved in visualization sort of as a career. And maybe very briefly before I do that, though, I'd like to learn just a little bit about who's in the group. So I'm curious how many of you are thinking about a career in Viz, or maybe you're students studying visualization. Maybe you have a position already, but you'd like to integrate visualization into that job. How many people sort of kind of align with that here? Okay, that's pretty good. Cool. And then how many people would consider themselves to be Viz practitioners? They sort of get paid to do that for a living. Awesome. Very nice. Okay. That's really helpful, just to sort of know who's here. So how I got started in Viz was a little bit roundabout. I am trained as a scientist. My undergraduate degree is actually in microbiology and immunology from UBC. I was in the lab. I worked for a little startup as a co-op student where we extracted DNA from dirt and then we cloned it into yeast and screened it to try to find novel antibiotics. So I did all of this kind of wet lab work. And I discovered computation a little bit later, and it was a better fit for me. I loved science intellectually, but didn't particularly like the wet lab work so much. So computation was super exciting. And when I was getting started, genomics was really taking off. And so, biology was becoming a much more data-rich discipline. And I ended up doing a PhD in computational biology. And it was during that PhD that I discovered that data visualization was a thing. And I did my PhD at MIT, and I was in the biology department, which happened to be across the street from the MIT Media Lab. I don't know if you've heard of it, but it's a really cool place. And I was very inspired by some of the people I met there. In particular, Ben Fry, who was a PhD student of John Lada's at the time. And Fernanda Villegas was there, later went on to Google and now is at Harvard. And so this visual is Ben's work, which influenced me a lot. And I was really excited to uncover this space where you do something that was very technical, but also had this aesthetic element to it, which is something I had always been wanting to integrate into my work. So that was really the beginning of my data visualization career, which was as a postdoc, in an academic setting. And throughout that career, I get asked this question, so what do you do? And, it's a little bit tricky to answer. I've been refining the answer to this question over time. Here's my most concise answer, which seems to be working so far. Feel free to use it if you like. Essentially, I design and build software interfaces to data. And I use both the words design and build because I do the designing part, but I also do some of the coding, prototyping, the actual creating of the software. And then that last word, data, super important. And if you take data out of this sentence, then you need to hire somebody else because there are lots of other people who are very qualified to design and build software interfaces, but you should probably hire them, not me. I'm much more specialized towards the data interface part. So I think, though, one of the most effective ways to explain your work is to just show it. And so that's really what we're going to do tonight, is to look at some projects as concrete examples. And I'm going to start with one from my postdoc way back when, and give you an example of sort of an academic visualization project. Then I'm going to tell you a bit about a project I worked on at Microsoft, literally 2 blocks from here, South Vancouver. And then I'm going to tell you about much more recent work, which I've been doing as a freelancer in my Pivot Data Studio company. So let's kind of dive in with this first project, which was done at BC Cancer as a part of the Genome Sciences Center. We have a really outstanding sequencing facility at Genome Sciences Center here in Vancouver. And so as a postdoc, this was one of the projects I worked on. And Sean Jackman, who was a PhD student at the time, came up to me one day and showed me this cartoon. And it was a printout of a graph that he had meticulously annotated with a yellow highlighter pen. And he said, "Hey, I heard that you do data visualization. Can you help me with my graph?" And so I said, "Sure. What are you trying to do?" And this is really where most of these projects begin, is understanding the core problem. So what Sean wanted to do was to inspect the output of his genome assembly algorithm, which is what this graph is, and to identify areas in that output that he could make better and essentially improve his algorithm, produce better assembly. So to help you kind of appreciate this project, I need to tell you just a couple of things about genomes. And the first is that they tend to be quite big. So your genome is over 3 billion base pairs long. And if you think of that, sort of typical picture in your head of DNA as a double helix, kind of like this ladder, and every step in that ladder is a base pair. It's 2 nucleotides which pair together in a very specific way. And those nucleotides have this abbreviation of A, C, G, and T, which you've probably heard of. Those are just abbreviations for their structures. And so I'm showing you a little snippet of a genome here, but imagine it being billions of bases long. So the way genome sequencing typically works is that, unfortunately, you cannot read a genome from one end to the other. It would be terrific if you could. There are some technologies where the concept is to pull a sequence through sort of like a nano sensor and be able to detect the bases that way, but that's not usually how it's done. Typically what you do is you produce very short sequences or reads from a genome. So kind of like these blue sequences, little fragments that come from some part of a genome. And the trick is, though, that those little sequences don't really have a lot of information about their origin other than the sequence itself. So think of it as like a bag of words. You sequence the genome, you got this big bag of short little sequences. So in the absence of some reference genome, the process of de novo genome assembly is trying to put all these bag of sequences back into the right order to infer the order again. So you can think of it as like a giant puzzle. And part of why that is difficult is that genomes tend to be full of repeat sequences, sort of repetitive elements, which make knowing which way they go back together much more difficult. So for example, here we have these strings of A's, and if I was to sort of assemble them back together, I would put the A's, together into one common sequence. And I could align sequences that sort of came from this beginning over here, and then they tile off in this direction, sort of recreating that central sequence. Then what happens is they sort of loop back around. So that little underlying sequence is actually the same as this one, which comes from that end. Then it runs into the A's again. Go back into the A's, and then we continue on into unique space. So that's why these repeats are a little bit complicated. And one way to represent that is as a graph. So in this case, we start with unique sequence. We go into that repetitive A sequence. We go out into something unique, which is that piece in the middle. Then we come back to the A's, and then we carry on. So you can sort of represent the assembled sequences as a graph. So with that in mind, maybe this picture of Sean's makes a little bit more sense now. We're looking at an assembly graph. It's sort of the graph structure that's been created by putting all those sequences back together. And so Sean, specifically, he wanted to follow paths through the graph, like his, shown with his yellow highlighter pen. He wanted to understand where the branching occurred, because that indicated, things that he could potentially improve with his algorithm. He also was really interested to identify short sequences. So if your assembly is going well, you're producing long, unambiguous sequences. But when they get really short, that's sort of where the errors lie. Okay, so that's a little bit of background about the problem. And that really helps us think about our design and what are we trying to do. So I took a look at his algorithm output, and it's structured like this, just like we talked about. The nodes represent the sequences, and the edges are essentially overlaps between those sequences. But if you were to sort of draw, like back of the envelope cartoon, of what sequences look like and their paths and their connectivity, you would probably, most biologists would draw it like this, where the sequence is actually a line, right? And their points of overlap are just where those lines intersect. So in this example, you can see that sequence 1 connects to 4. That's in this graph too, obviously, 1 to 4. And you can see that 1 goes out to 2. That's here, 1 goes out to 2. But that middle representation makes it immediately obvious that all 4 of those sequences share common sequence, and that they have that as an overlapping unit here. To be able to identify that in the output on the left, it's much more difficult. You have to do a little bit of mental gymnastics to see that all 4 of those sequences share an overlap. And so the first thing that I did was to transform the output of the algorithm to match what was much more, cognitively easy to understand, right? I want to go from 1 to 4. I just want to follow a path sequences. And so in that representation, the edges are now the sequences, and the nodes are just the places where they come together and overlap. So I can follow this graph of sequences and just follow those edges along. And I get a much better sort of one-to-one mapping with how you would normally draw that. So that made the graph much easier to understand. And I think that was a general insight, is that transforming your data to better serve your task. It's really important. I think we have a tendency, to take a data set, just visualize it directly. And obviously that's a great place to start. But keeping in mind, what is your user trying to do? How do I make that as easy as possible for them? Eliminate as much of the cognitive load as possible to help them just look at the visual and move on with the task question that we're trying to answer. The other part I want to tell you about the story is that other sort of challenge that Sean had, which was trying to identify different sequence lengths, right? He was interested in short sequences. So now we have this graph where the edges are the sequences. How are we going to show sequence length? What are all the possible ways, we could do that? So we thought about, edge thickness, right? We could make thicker edges be longer sequences. There's only so much aggressiveness in edge thickness. So that might be a little bit challenging if we wanted to get a bit more quantitative. We thought about color, right? You could put on color gradient, maybe dark is longer, light shorter, something like that. But again, it's not particularly quantitative. And so the idea was this. And essentially, you now take the two nodes and your sequence, sort of squish them together. And now the squished sequence becomes this wave in between. And we sort of built a slider so that one sort of oscillation in this wave corresponds to like a fixed number of nucleotides, let's say like 100. And so that means that short sequences, things that are below your threshold, become a single arc. They're super easy to spot. And the other stuff you can almost estimate at a glance how big they are. You know, oh, this is maybe, I don't know, 1,500 nucleotides long. And then the stuff that's big, you don't really have to worry about because it's assembled well. It's been taken care of. And it actually started to form like a, almost like a solid shape. And actually these sequences have a directionality. And to capture that, I made them almost like a leaf. So they have a thicker base and they move out to a tip. Anyway, the result was this fun, organic looking visualization. Here's a picture of one of the visuals I made in the first prototype. We did some other stuff, color, and there was a bit of additional information I won't get into tonight, but that's the general idea behind the design. And this tool was called Abyss Explorer. Abyss is assembly by short sequences. That was the name of the algorithm for generating the assembly in the first place. And this was a IEEE Viz paper. Actually won a Best Paper award, which was pretty nice. And if you're interested in it, you can find the original paper. It's on my website as well. It's certainly easy to find. And somebody who worked on this project, not so much on the original prototype, but who worked on the subsequent software iteration where we sort of built some analytics around this representation. He is here tonight. Where are you? There he is. So Cumming was my co-op student on this project a while ago. I'm not going to admit how long ago, but a while ago. And anyway, it's fun to see you here. Okay, so I think part of what I wanted to weave in tonight was a few comments about what the practical work looked like in all of these different environments. Hopefully that's of interest to you. As a postdoc and working in an academic project, you really get to do a bit of everything. So, the user research, the direct interaction with John, that was sort of all on me. The design and all of the implementation of this, it was written in Java, actually. I sort of did all of that. And then later, as I mentioned, with Cumming, we sort of moved more to a small team that developed this into a bit more of a software product. And subsequent work that I did at BC Cancer was of that structure, so creating a team of engineers and students to try to build software inside an academic lab. And I think a part of this job is certainly also worrying a little bit about money, right? So if you're in an academic situation as a student, as a faculty member, finding funding is usually part of that. So I worked as a research associate for about 5 years after my postdoc at BC Cancer. And a big part of my job, in addition to sort of managing team of engineers, was also finding funding for those projects. And so, just briefly what that academic experience, that academic environment was like, I think it kind of goes without saying there's a huge amount of creative freedom, right? There were almost no constraints on that project, really. We could design using any stack we wanted, kind of use any visual representation we wanted. I had wonderful direct access to users. I don't think that's always true, but I think, in academia, because you need to sort of wear a lot of those hats, you tend to be doing the user research yourself. The user base was definitely small, particularly for the projects I worked on, that was generally true. And I don't think that has to be true. I'll point you to this really nice blog post by Alex Lex, where he reflects on a tool called Upset. Any of you heard of Upset? Have you heard of Obsessed? Well, anyway, it was an academic project, which started out as a biz paper, but they did turn it into a package that became quite popular. Essentially, it is for dealing with the case of trying to create like a Venn diagram, many, many different sets, showing the overlaps with all those sets. And so he just reflected on how he went from an academic paper to something that was more widely adopted. I think, of course, keeping in mind that the output here is papers and not products. That academic research lab is really not designed for producing software products. It was, I think, challenging to recruit engineers to that environment. People don't typically look to an academic research lab as a place to find a job. And I think also related to that, there's sort of a lower financial reward. Anybody's a PhD student or student in general, that feels like. And so that, that's certainly, you can do well professionally in academia, no doubt, but it takes time, and the pay grade tends to be low. So I essentially, was looking for a change, and I'm going to shift to this other project, tell you a little bit about the work I did at Microsoft. The way I got to Microsoft, you might wonder, how on earth did somebody with like a PhD in computational biology go work at Microsoft? Like, how do you go about getting that job? And so, it came from a collaboration between BC Cancer and Microsoft that was mostly computationally focused. It was about, genomics and Azure, that kind of thing. But at the time, we were working on a very new kind of data that was three-dimensional. And the head of Microsoft Vancouver said, hey, you guys should see HoloLens. So I got to know about HoloLens, which is Microsoft's mixed reality platform. And I ended up mentoring two groups of Microsoft undergraduate interns. Really cool project where we visualized this 3D data on HoloLens. Found out that, the head of Microsoft Vancouver at the time was starting up a new product team and was hiring. And I was definitely interested in making a change. I think for me, I love products. And it took me a while to figure that out, but I really enjoy making software and making software that people use and that adds value. And I didn't really feel like I could do that terribly successfully in an academic environment. That's not really what it's for. So I ended up, through that, going through a full interview cycle and being hired as a Microsoft designer. So I think the story there just is that when you're given the opportunity to talk about what you do and explain what you do, particularly when it's something that's a bit newer, like data visualization, it goes a long way, and people see the value once they understand what it is that you do. But it's sometimes quite difficult. It's very difficult to communicate that purely on paper, in a stack of CVs. Okay, so I'm going to tell you a little bit about this other project that I did. Well, at Microsoft, most of what I did there is not public. I can't really talk about, but this project is public, and most of what I will show is sort of available, online in their documentation. So we're going to switch gears pretty radically. This has nothing to do with biology. Don't worry, there's no more talking about DNA. It's over. Made it through that part. So this project is about manufacturing, and we can start with the same question though. What are you trying to do? Well, in this case, people are trying to make a manufacturing process more efficient. Optimization is extremely important in some of these settings. And so to do that, the product I worked on was called Dynamics 365 Guides, and it was a HoloLens application that essentially provides holographic step-by-step work instructions so that a worker can put on the HoloLens, walk up to some complicated piece of equipment and be guided holographically through what to do in a particular process. And so the guide instructions essentially were on these holographic panels that would move with you or that you could pin. It was all gaze controlled. So essentially there was a gaze controlled piece of UI. You sort of guide at the next or gaze at the next button. It would, detect your gaze, fill up, and then once complete, move to the next slide so that you could be busy with your hands doing the work. And later this application was integrated with another product called Remote Assist, which is essentially Teams call inside your HoloLens. And the cool thing about that is you could now have a remote expert sharing your view and then also making holographic annotations of view. So that's sort of what's shown in yellow there. They could say, I want you to take this wire, connect it to this wire, and walk you through it. So that had huge value. You can imagine not having to fly an expert halfway across the world, but rather just have somebody local put a HoloLens on and be guided remotely. That was extremely useful. So from a little bit more detail about how the app worked, it had a desktop component, which looks a bit like PowerPoint, honestly. This is where you make your instruction slides. And then you could drag and drop 3D assets to that slide. They could be something that came with the app. They could be something custom. And then you could put your HoloLens on as an author, and you could position those assets in 3D. So maybe you have some piece of equipment, and on this step, you want to, place an arrow on a particular part of that equipment. You could sort of grab it and use your hands to position it, and it was all anchored and would persist. Okay, that's sort of a quick overview of what that application was like. All of the documentation is there on Microsoft Learn, and there's tons of YouTube videos of this thing if you're curious. So coming back to sort of the data problem, we're trying to make a process more efficient. Well, more specifically, users wanted to take advantage of measurements of time per step and figure out which steps were taking, say, too much time, and then use that for optimization. So the HoloLens, we instrumented it with telemetry, and so when somebody moves from step to step, all that data is stored and recorded, and you can keep track of, how long each step takes. So to design a report, a time tracking report, we started with some industry standards, right? This was the manufacturing space where they have a lot of, well-established methodology to optimize process. So here are some examples from lean manufacturing. This is called a process study sheet, where essentially you have every step in your assembly procedure together with observed time. This would be done by like somebody with a clipboard, right? Sort of watching people. And they would, watch several different people and manually make observations about how long it took. This is another kind of chart that is used in sort of lean manufacturing processes. It's called an operator balance chart. And here the idea is you have multiple operators performing different assembly tasks. And you're going to measure how long it takes to complete each one of those tasks. But ideally, you don't want certain tasks being completed much faster than others. Maybe instead of having 6 workers, it's better to distribute that work more evenly across 5 so that there's much less downtime. So this is a visual that's used in that field to really quickly identify imbalances compared to some target time. And so taking inspiration from that, I built this report called Guide Analytics. And in this case, what we're looking at is average completion time of individual tasks. And in this case, a collection of steps is grouped together in something called a task in guides. And so the time it takes for each one of these steps is sort of summed in a stacked bar chart, and you can at a glance figure out which tasks are taking a long time maybe taking too long. And then based on that study sheet, sort of built a tabular view where you have every step described together with its average time and a standard deviation. So you could sort that table by standard deviation, figure out which ones have the most variability in them, and maybe target those for me. And then the last chart in this essentially shows individual sort of runs through a guide. So each set of dots corresponds to a step. And then the dots represent different sessions moving through that guide. So you can, again, compare to some target time and find how much variability, how much spread, or are there outliers in certain steps? And those might be steps that you want to go and optimize further. So we put this all together into this report and may recognize the style. This is all built with Power BI, which is no surprise, we're with Microsoft. I think one of the super interesting things for me is that the data in this product is all private to the customer. So if you think about that for a minute, that means we ship this report to a customer and they configure it to connect to their own private, Microsoft tenanted data, which means that me as a designer do not have access to the data. That was sort of mind-blowing as a data visualization designer, that I didn't really have direct access to the data. It takes sort of a minute to appreciate how surprising that might be. But anybody who builds a dashboarding tool, a Tableau or a Power BI, that is their normal, right? They don't always see how people use it. So we kind of obviously had to use some simulated data. That's what you're seeing here. And that's what we shipped with the report as kind of a built-in example. Now, I'm being a bit extreme. I mean, obviously, you can have collaborations with customers, sign specific data agreements where you agree to collaborate and see their data. But generally speaking, a company like Microsoft takes that data privacy really seriously, and it's pretty much impossible to access. So in light of that, compared to my first project that I showed you, where I just sort of went over and sat next to Sean, and I was doing my user research, I could describe and we could go back and forth. Here I didn't really have that access to the customer. And so one of the things I did was I phrased every chart title as a question to kind of help a new user understand what the chart was for. So for example, how long did each step in a session? How long is each step in a session? Something like that. In terms of constraints, all the colors sort of come from the Microsoft Style Guide, of course. And one of the things that was really interesting to me was things like accessibility standards. So this report needed to work with a screen reader. And I'd never used a screen reader before. It was really cool. You had to make sure that the tab order worked correctly. And I really appreciated sort of having my eyes opened a little bit more to the much broader types of users who might be consuming what I was making. And so that's something that I really appreciated and I think will, carry with me forward. So in terms of what daily work looked like in this environment, we worked in multidisciplinary Scrum teams focused on shipping features. I think the work tends to be much more contained to a discipline. For a designer, you're given sort of design tasks. Data scientists, you get sort of more data scientist tasks. There's a little bit less crossing lanes. You'll tend to mostly swim in their lane. As a designer, I worked on defining the problem, and unlike in the first case where I was working with the user directly, here I worked with product owners. I worked with managers who were especially focused on engagement with customers, and there was a whole user research team. I mean, what a concept! Like, there's this enormous team of people who are very skilled at user research, and so you work with them. That was really fascinating to kind of learn their process. In this case, I actually designed the UI directly through prototyping Power BI, which, I think for a product like this, a dashboard like this, you could imagine first sketching it in Figma or something like that. But in this case, it actually made sense to just build it with some simulated data directly and iterate there. Once we had an initial product, I then collaborated with interface designers who did a pass on the layout and the color and all of those things. So we would call this an art pass. Nobody did an art pass on my postdoctoral project, that's for sure, but it was really fascinating to kind of see that process. In the end, I actually built the Power BI dashboard that shipped to customers. Not sure how typical that is for a designer to build the thing, but I think that's where the power of being a hybrid person, comes in. You can sort of do things like that. Later at Microsoft, I actually switched and became a data scientist, and some of that was that I never wanted to be separated from the data, and I kind of wanted that like baked into my title. It's like, as a designer, there's lots of designers at Microsoft who know nothing about data, right? That's not the type of design that they do. And so I really wanted to make sure that I was connected to data. And I felt that, being a data scientist was maybe a better term. So in that case, though, you do then, get tasked with doing data scientist sort of things. And so one of the things I did there was we did an iteration on this project. And so redesigning the data schema and thinking about how the telemetry off the HoloLens was actually implemented and how we can make it better to improve data quality. So that's like, how exactly is the user session defined? And are there cases where that's failing and leading to poor data, right? How do we improve data quality? That was sort of more of a data scientist job. Okay, so sort of to summarize this part, many more constraints. That's sort of obvious in every dimension. The platform we work on, the types of charts, the colors that are used. In my experience, the collaboration with customers was indirect. I worked with other designers who had better connectivity directly with customers, but that's certainly not a given. It will be through people who have those customer relationships. But the reach is global. Like, it was totally mind-blowing for me to be on this team. Like, we went from a little pilot project to shipping internationally. Toyota uses this product. You can find YouTube videos of Toyota using our product. And as somebody coming from a very small research lab, that was just kind of exhilarating to know that many people were using what you had built. It was all about products. Nobody cared about papers, that's for sure. Very, very, very different. But I liked it. I really liked it. It was exciting, to be on a product team. It was a wonderful group of people, and to get together every 2 weeks and have people demo their work was super inspiring. And I will say that there's definitely a higher financial reward that comes with, working in an environment like that. Okay, but as usual, I was ready for a change. Wanted to do something else. And I think that there were a whole bunch of reasons for that. Probably, though, the biggest is that I really love data visualization. I wanted to be doing that more of the time. And I think, being a data scientist on a particular team or a designer, there's a much wider range of things that you're asked to do. You're also reorganized a lot, certainly in an organization like that. Massive structural changes are routine. So you might have a new manager, you might be on a new project, and I think I wanted a little bit more control of my day-to-day work. How are you guys doing? Is this good?
Yeah, very good.
Yeah.
Does anybody have questions?
Used to be any kind of like tensions like now, like that's why.
What's she gonna do now? Well, I'll tell you a little bit about what I did next because because I think it's interesting. It's not really what I expected, but I think going from big company where you end up getting quite specialized, that can be awesome if you're really good at that thing, sort of accelerate up that path. I was a little bit like, well, I want to do some of that, do some of that, do some of that. I want to wear all these hats. And that was a little bit harder. And so I thought, you know what? I think I should go to a smaller company, maybe more like a startup, something a little bit tinier where you have to wear more hats. And so I actually left Microsoft to join a startup together with a bunch of other ex-Microsoft people. And it was all about controlled environment agriculture. It was pretty different. And so that was all about growing plants in a container, pretty much, like in a controlled environment. It was cool because there was a ton of data flowing off of that device. Super interesting user use cases. You have a farmer who couldn't care less about what's happening inside the device. You have to communicate data to them. And then you have an engineer who wants to know about every single motor inside of it. So super interesting interface design problem. And they also had a wonderful data science team, a fantastic UX team. They had awesome engineers, and I was being hired as their director of information design. And I could just, cool, like I can collaborate with all these great people, and we're going to make this really neat product. So there was a little bit of time between when I negotiated to start, like sign the contract, and when I actually showed up. Some stuff happened in that time, and when I got there, within a few weeks, they pretty much laid off the entire software team. And actually, the company downsized more or less to sort of a core unit. I think I worked there for a matter of weeks. So it was a bit of a shock to the system. I knew joining a startup would be risky. I had no idea it was going to be that risky. And I think anybody who's gone through a layoff, it's a bit of like being punched in the stomach. Like it's just, it's a hard thing to recover from. But it got me thinking. It gave me a little bit of time to think about, what I wanted to do. And during that thinking time, I got an email from a colleague who was at Harvard Medical School, and he said, "Hey, what are you doing?" I was like, "Wow, your timing is perfect. I'm not doing anything." Said, "We have this like 3D data. We kind of want to put it on a mixed reality headset." And I was thinking, like, you're like the only person I know who would, sort of has done that. And it was hilarious because it was full circle to the intern project that I had worked on probably 5 or 6 years earlier. The technology had matured massively and was now sort of ready for prime time. And so he and I worked together. We did a sort of pilot project and built this really cool application for MetaQuest 3 to look at 3D single cell resolution data. I'm not going to talk about that project because it's quite academic. It has a lot of the flavor of the first one. But that sort of short freelancing gig really inspired me that, you know what, maybe this is where I belong. Maybe this is a good format for me, is to do freelance. And so I have moved in that direction and formed a company last year, and I'm mostly consulting sort of for pharmaceutical biotech companies. But I want to tell you this last story that comes from my short time at Pivot Data Studio. This is a personal project, mostly because stuff that I'm doing now is still confidential and I can't show. I hope that at some point I will be able to show, but it's still early. So I'm going to show you something that I've worked on for fun, and I think it has a completely different flavor than the other 2 things that I showed you first. But the process is the same. What are you trying to do? Right? What are we doing? What is this for? Well, I got quite curious about the data that's being collected on my watch, and specifically the sleep data. There's sleep tracker. I'm sure lots of you use it. I was kind of interested in like what are my existing patterns in that sleep data. And to be honest, I also was just kind of having fun. It was like, what visual representations could I use for this data? Taking the, analytical hat off a little bit, I can never remove it. I'm a scientist fundamentally, but like being a little more playful with the representation part of this. And also from a technology point of view, I was kind of curious to dabble in other languages that I hadn't gotten to use past years. So this might be familiar to many. This is what the Apple Health app looks like. This is what the sleep data looks like. So on the left is an individual night's sleep. And you can see that it gets categorized into 4 different states. So, moving through the night from beginning of the night to the end of the night, kind of move through these different states. And awake is up at the top in red. And then core is really dominant all through the middle. And then there's deep sleep here, which is in a much darker blue purple color. And then there's some REM, this rapid eye movement phase, which is, typically associated with like dreams. So that's shown in that second tier. And then Apple provides this view when you want to look at many days of sleep. And essentially, each night is one of these vertical columns. And we kind of have like a bunch of stacked bars that show you those states. And I don't know, guys look at this stuff. I think it's sort of fun. It's fun to look back later at it. You can see that I sleep in on the weekend. But I only sleep in on Sunday because I have to take my daughter to a very early morning activity on Saturday. This was Thanksgiving. I got to sleep in both days. That was great. And I've recently started consulting for a company in Austria. So you can see that I had to get up at 6. We have 7 a.m. calls. That was a little bit rough. But anyway, it's fun to look at these patterns. I was curious if I could do something else. What other representations could I use? And so I kind of wanted to look at that much data, maybe a month of data, but could I try to use that kind of a picture instead? So here's was like my first go at it. So every night's sleep is a line, it's one of these rows. And the beginning of the night is on the left and the end of the night is on the right. And then when I fell asleep, either it was early, further to the left, or it was later, further to the right. And then the states is quite similar to what is in the original Apple case. So the awake points are these peaks, the deep sleep are the lowest vertical points, and then the REM and the core are kind of in between. Actually, they're pretty hard to distinguish. I don't have a lot of room. There's only this many pixels, right? It's not a lot of room to express, but you can get the gist. To make those states more obvious, I just made them thicker, essentially, just gave them a upper and lower bound. It's a little bit blobby, I don't know. And then I tried adding color. So here I'm coloring the awake in a somewhat similar color scheme to the Apple data. So you can see I tend to have a hard time falling asleep, and that's where I wake up most. Is at the front of the night. Some of them are more obvious than others. So I think this sort of worked. It was definitely difficult to tell the difference between some of the other states. And I think I actually kind of got myself into like a blue corner. There's only so much blue, particularly if this is your background blue. There's not, to try to create that many different states of blue is becoming hard to distinguish visually. So this was another experiment where now here are our 4 states, and I'm going to draw a line through the night going between those states up to deep sleep and so on. But the difference here is I'll fill it in as an area. And then I'm going to wrap it around into sort of like a radar chart. So this is kind of fun. I organized it this way so that the awake parts kind of like sliced into the area. They're like cutaways, right? When you're awake, you don't have any blue, you don't have any sleep. And then the deep sleep pushed all the way out to the end. So it was like those extremities. So this is what these like sleep spots kind of look like for 4 weeks of data. And so each week is a vertical. And then I shifted the dots to the right. I think it was according to when I woke up. So you can see the weekends were shifted. I tended to sleep in more. Here, I went to bed earlier. I don't know if this works. It was fun to make. I think they're a little bit harder to, I don't know if it works that well analytically. I mean, you can kind of see some of the nights that are more chopped up, some of the nights that have bigger blobs of blue. But I wasn't totally convinced. So then I tried this, and this is a little bit closer to those original stacked bars. Each night is a vertical strip. In this case, I'm making so each square corresponds to a sleep segment, and it's colored by its type. So the orangey ones are awake. These big, the sort of medium blue is the core sleep. These almost grayish ones are the REM, and then a dark blue is deep. And I made the squares bigger based on their duration. So the longer the section, the sleep segment is, the bigger that square. And then I also tilted the square according to duration. So the shorter it is, it's a little bit more upright. Longer it is, the more it tilts. And I was doing that to try to create a little bit of like a falling sensation to it. I think again, I got stuck in that blue corner. I think I still had the same problem with resolving the different states. And so one of the things I decided to do is like clarify the story of this a little bit. What am I trying to do? What am I trying to say with it? And so I went back and looked at the data, and this is kind of looking at an overview of many, many days or rather many, many nights of sleep. And I normalized each night between 0 and 1. So this is the beginning of the night. That's the end of the night. Doesn't matter how long I slept. They've all been normalized to 1. And then I'm just counting and binning the number of sleep segments that fell into each part of that night by their 4 states. So, I could have plotted duration, but this is closer to what I was visualizing before, just number of segments. And you could see that, awake has a little bit of a bump at the beginning of the night, which, we noticed in the other chart. And spikes, maybe that's some noise. Maybe I'm actually awake, and that's just a little bit of noise in the wake up time. Core certainly has the biggest numbers, but this sort of caught my eye. I thought this was interesting. The deep sleep is in the beginning and tapers off, and it's sort of taken over by REM, by dreaming. There's that transition between those two things. So I decided to try to emphasize that, and that was this iteration. So in this case, the squares are only the 2 states of deep sleep at the top, kind of in blue, and the dream state, this REM state, in this kind of reddish purple color. And so again, each night is a vertical. The line, I don't know if you can see it at the back, but it's like fragmented. So it's just the core sleep segments. And so the awake part is like the absence of the line. It's where the line got chopped. So it's there, but it's very understated, really de-emphasizing the awake and really emphasizing this transition of the deep sleep at the top into the sort of dream that happens at the end. I'm not sure how well this palette works sort of from a color blindness perspective. It probably could be improved. But that was sort of a version that I was reasonably happy with. And so then I tried animating it a little bit to give it some interaction. All of this was done in D3, haven't really used D3 before. That was the other thing. So I was really curious to give it a try. And it is immensely powerful. You can have the power to put pixels magically everywhere you want, which is terrific. Anyway, I also was curious to see if I could visualize more data. So this is a whole year of sleep. And all of the sleep in the sort of format that I have that it gives you automatically is in our current time zone. And therefore, you can see when I traveled to Europe, we essentially invert day and night. That is why you feel so terrible when you get off the plane. So those were about 10 days spent in Europe where we flipped day and night.
You see the jet lag.
Do you see the jet lag? Yeah. Yeah, anyway, there's detail in there. I'll just leave it out for now. But anyway, so the thing is it's very dense, right? It's hard to see. And so I experimented with using a bit of animation. And so this is sort of applying like a fisheye kind of lens to it so that you can like zoom in a little bit better. But then it all kind of like squishes together and gets a bit smaller as you move to the sides. The other thing I wanted to try with this, which I hadn't really ever done before, was to make sure that it worked on mobile. And it works really nicely, actually. You can sort of it's fun to play with and drag it around like that. All the stuff I did before was really, like for scientists or computer, maybe some of the guides analytics stuff. You could imagine somebody looking at a report like that, maybe on an iPad or something, on an operations floor. But I had never done anything for mobile, so this was kind of a fun thing. If you're interested in those, they're available as observable notebooks and in public. The one I showed you at the very end isn't quite there yet. I'll probably publish it in the next few days, just doing the last couple of tweaks. So anyhow, this, trying to wrap this up here. What does daily work look like as a freelancer? Well, there's the client work. And so far, for me, this has all been remote. I think a lot of us are, working remotely these days. A lot of international clients, sort of US, Europe, that kind of thing. I'm doing, user research, requirements gathering, defining the problem to solve, listening to users talk about what they want to do. I do a lot of sketching and prototyping in Figma. That's actually been a great way to ideate. Sometimes I'm prototyping in code with sample data, but I think what's been most interesting so far is the value is in helping them figure out what to do. Often they already have engineers and they don't necessarily need me to build it. They often will have computational pipelines. They will have data scientists. They don't necessarily need me to process their data. But what they're not sure what to do is like, well, how do we show this data? What do we build? What is the interface? So it's sort of the art of figuring that out, listening to the users, sketching, iterating, and figuring out what kind of solution is actually needed. Definitely part of my day is involved in looking for new work. So that's a reality. And I get to be in charge of company operations and finances. So, you definitely get to find a lawyer and help them write a contract, or help them help you write a contract. But I also have been doing some personal projects, and I think, doing those sorts of short, playful explorations, I think for a designer are super useful. And I often didn't take the time to do it. Microsoft was really great. We had hackathons and there were opportunities like that. But I think it's really valuable to carve out a little bit of time to explore new technology, try things you've been curious about, because you go back to your other work with sort of a new energy. So how does freelance compare to all of these other things? Well, you have to wear all the hats, which has been actually great fit for me. I really enjoy being able to do different kinds of things. And related to that, the projects are much more varied. The stuff I worked on so far is actually reasonably long term. The project with Harvard Medical School was 8 months in the end, which is, I think, a decent amount of time to produce something. I work as an individual. There is no office culture. There's nobody to, chat with particularly. My husband works at home, so I guess that's the office culture. So we get to, have lunch together. But so far, this hasn't been too much of a problem. I really like people. I like staying connected to people. So I have definitely cultivated, social meetings, marketing with clients. I don't actually feel that isolated, even though I'm sort of technically working on my own. Financially, this is obviously much less predictable. So if you're considering this direction, you have to be prepared for that kind of risk. And you get to have all the freedom, all the responsibility. Okay, so I have a couple final thoughts. These were really geared mostly towards, people earlier in their career. So, if you're further along, bear with me. Maybe there's some utility here. I got this advice from somebody. They said, figure out what are your non-negotiables. And that actually was really useful. It's like, what are the core things that you fundamentally, need to be true? And that could be all sorts of things. It might be the values of the company you work for. It might be the city you live in. Maybe you can't move. This is where you have to be. It might be finances. Maybe you need to make enough money, to support your family. Maybe there's certain financial constraints. But what are your criteria? What are your non-negotiables? And when you get clear on that, it can sort of help shape your next step and decide what to do. This next one, I think, relates back to what I said earlier when I got the job at Microsoft. They don't realize yet that they need a visualization designer. I think it's still quite a new thing. When you explain it to people, they say, wow, that would be really useful. They didn't necessarily know that that was the thing. I have been pleasantly surprised to see job postings for data visualization designer, visualization analyst. There's all sorts of terms out there. One that I personally like is data experience designer. You're pushing for that, right? You're like a UX designer, but it's the data experience. Anyway, it's certainly growing. But I think in a bigger picture to this is that throughout my career, I've discovered that there's a lot of unadvertised jobs. So there's jobs that are advertised, and then there's the jobs that are sort of in the works, or people are thinking about, or maybe because they met you, they're like, oh, wow, we should maybe do this right now. And so I have had success in reaching out to people who think they're doing something interesting. I'm interested in the company, using my network to kind of have those introductions, and then just having a conversation. And if nothing else comes from that other than an interesting conversation, that's fine. But often having that chance to describe what you do very often leads to something. Oh, you should meet so-and-so. Or actually, we're hiring, and I didn't think about hiring this particular role, but that sounds like a really good fit. And I guess the very last thing I want to say is that, remember that your experience in another field can be an asset. So if you are starting, career number 2 or maybe career number 3, you might feel like you have all this experience in something else and that's sort of lost. And, I had all of this experience in biology, and I was working on a, application for manufacturing. It's like, what am I using that? In what I'm doing now, I'm definitely leveraging that biological knowledge again. And I think that what happens when you do that is that you become kind of this magical entity. You have this ability to go between fields that other people don't. And it's almost impossible to hire somebody like that, right? So, wow, you know all about finance and you can make data visualizations, or you understand, real estate and you can make data visualizations. Like these things can be real assets. That is all. Thank you.
Questions or questions?
How many designers were on that Microsoft project, and how long was that term? Like from zero? Were you there at zero to launch?
I was not quite there at zero. They had kind of figured out the use case. I was sort of sad to miss that part, actually. It would have been really interesting. They figured out where the market value was. They kind of already latched onto that. I worked on that project 2 to 3 years. It's actually still running. And we went through that cycle of, pretty much a prototype, some customers to a private preview to a sort of public preview to kind of full launch. I don't remember the exact timing, but it was, maybe 2 years. Yeah. Oh, you also asked about how many.
How many designers were doing what you did?
Yeah.
Anyone?
Doing what I do, I was the only one. So there was no other data visualization person. And to be totally honest with you, a lot of that product is a 3D experience. It's not a data product. So the data piece was small. There were maybe a dozen designers, mostly people who came from 3D animation, people who understood mixed reality extremely well. We had a couple of more 2D UI people. The team was maybe 50 total.
Thanks.
Sorry.
Thank you for the story. Sorry, what? Thank you for your story. It was really nice to follow. You're a great storyteller along with a great designer as well. My question to you is, you have with different companies and different projects. Obviously, fall into strategies. Now that you have a freelancer, you do creation, designing, and deployment as well. So if you're doing all of it, what are some challenges or things to avoid during this process as well? So what is the problem? Sometimes you're using fitness, sometimes you're directly. Someone who has to do it on it. What are the things that you can do?
Yeah, so if I summarize that question, given that I'm a freelancer and I have to do everything, how do I do that well? Like, what are the difficulties there, and how do you be successful? I think that actually what I have realized in the short time that I've been doing this is to kind of specialize on the thing that I do well, and focus mostly on that. And so, when I started, I thought I would be doing a little bit more of everything. Like I thought I would be maybe doing a bit more software development. But the more that I've talked to my clients, it's in that special spot where they have something that's quite nebulous, right? They don't really know what to make. You ask them what they want to do, they're not even sure. They know they have some data, have an idea, but sort of, I think what I do well is taking that ambiguity, creating structure to it, talking through it, listening to users, and then beginning to iterate and design, come up with a solution, which then ultimately their engineering team will build. And their data scientists will, flow data into it. They don't need me for that. So I guess my advice would be to figure out what you're best at, and it may take some trial and error, but to hone it in on something that has high value, and then just keep doing that. Does that make sense?
Question, Greg.
Hi. So when you transition, like as a freelancer, what were like some of the challenges into convincing like potential new clients that they actually need good data visualization, that storytelling?
Yeah, it's a great question. So how do you convince, how do you get clients to hire you? Really, it's like, how do you convince them that this is something they need? Like full disclosure, I haven't been doing this that long. So it's been maybe a year-ish The company is younger than that. It's only about 6 months old. So far, I have been fortunate in most of the work I've had has been through word of mouth. So I did this, and then they're like, oh, you should meet this person. So I meet that person. They're like, oh, this is a good fit. It chains like that. And I think, hopefully that pipeline I can sort of keep developing, and that'll be a source of work. I have also, of course, been approaching people, in my network who I know, where I think the company this might be a good fit. And so then you have that conversation where you're sort of pitching it. And it's not always easy. Like, I think you are sometimes talking to somebody who's just very unfamiliar with this discipline. And they have their computational people and their engineers, and they're, what is it that you do? Like, why do we need that? So again, I think having concrete examples to show, to illustrate, super useful. It's like, well, for this company, I can tell you in general terms what I did, and here was the value. So it's like explaining by example, I think, is the most convincing. But that's something I'm still working on for sure. It's progress.
She moves too fast.
Hey, thank you so much for your talk. I really appreciate it. It spanned quite a few different bits. So I personally love self-experimentation. Like, that's what I spend most time on, just building visualizations and software for myself. So I love that. Yeah, you're doing that, and it's just one thing ever. I was really it was really fun to watch the first demo that you showed of the Abyss Explorer and so on. What I'm wondering is, you talked about the graph, like the initial obvious visualization, and how you go from that to the more intuitive but sort of deeper hidden one. While I think intuition plays a lot of role in everything that I do, what are some frameworks, or like design thinking in design is a great sort of framework that I sometimes lean on when I'm like out of my depth. What are some frameworks in database? Because I'm not a database, I didn't study that officially. What are some frameworks I can lean on to like go from obvious to like, this is the real gem in there? How did you know?
Let's see. So talking specifically about almost like picking the right representation. It's like, how do I know what to use?
Yeah.
Yeah.
Process. I'm not really
Yeah. So, the academic visualization community is extremely interested in studying, theorizing, measuring empirically, what works well for what type of data. And there's some pretty good general rules of thumb that you can use. Is it quantitative? Do you need to tell the difference between 15 and 10? Or is it qualitative, right? I just want to know if it's high or low. You can pick different representations that way. Tamara Musner, who's a local Vancouver professor, at UBC, she wrote a wonderful book, data visualization sort of reference book. I would highly recommend that. She sort of breaks down, marks and channels and all of this sort of formality of how to think about it. So that would probably be my main reference. And then I think layered on top of that, again, is just like listening to what people want to do. I think we get really eager to go to the solution. And often, like, people are talking about solutions in the first meeting, right? They're like, I want it to be 3D, okay? Like, I want to like fly over it. Right? It's like, well, okay, but what do you want to do? What do you want to do? What is the problem that you're solving? And that, to me, if I just like relax, settle into what they want to do, all the creativity flows. It's the design comes from constraints. If you don't have constraints, what on earth are you doing? Like, you're not going to make anything interesting. Once you constrain it, and it's like it has to do this, it has to do that, it has to do this, then that's sort of, you can be really creative in that space. So that's sort of the part that comes on top of the core principles.
If I could quickly follow up, like, I think the divergent and convergent process is like that's the point you're focusing on. Is there like a set of things you always think like, this is what I'm too attached to my design right now, I shouldn't do that, or something like that, like in that divergent thing? what are your things that you perhaps do as like, these are the things I look out for. I'm going to try and see something there.
Yeah, so the follow-up is the kind of like things you notice along the way where you're getting too attached to something. Maybe losing your creativity a bit. Yeah, that's a harder one. I mean, honestly, when I am struggling with something, I get up and I do something else. I walk around the block, do the dishes. I don't know, listen to some news podcast that's 10 minutes long, and then I come back and I'm like, oh, that's what I should do. And your brain, it's like it's processing. It's it's in the background, and that I always find extremely helpful. When I'm stuck, I just stop, and take a walk.
So I do that. Yeah.
Work. Thank you, Cydney, for the presentation. My question was about what you're doing. So if, let's say, you are taking away the knowledge of, since you mentioned you study postdoc, and so you have the fundamentals. For someone who's entering this field, because for data, the first thing that comes to my mind is like SQL, because I used to do university. So what is it that like I understood the Apple project you did, but the other two were too technical, so I just took some notes. But if I like take a screenshot from the data that you showed us and like feed it to AI, it's going to explain it all in details to me. So like what's the difference between the job you're doing and the information that I can easily like extract from just a simple search?
So so you mentioned AI, and maybe also there's a simple, being able to just ask, here's my data set, and make some charts. So that's a great question, and I think it's on a lot of people's mind. How does AI fit into this kind of a workflow? So I think that those applications are really great at helping you get started. They help you go from like the blank page to the first draft. And so, from like, think about like the writing analogy. I need to write this letter, blank page. I can feed in something and kind of get a first go, and I can edit that. And that makes me productive because I'm accelerating, getting over that hurdle faster. So you could certainly do that kind of thing, Viz. And tools like Power BI, you can now do exactly that. So you can pivot your data set, say, make a dashboard, and it'll make you a dashboard. That's super cool, right? You just got going. And you can still edit it, still analyze it, and you really should, because you need to make sure that it's doing something reasonable. You could certainly have data in there that's the same type, but not fundamentally comparable, given how it was generated. So I think you still need that expert editing. Or for the kind of things that I've been doing, they're sort of even more niche. So if we take this like 3D database project, there's no way I can, we're not there yet. Like we can't do that yet. And I think similarly for some of the sort of user requirements gathering, the customer doesn't know what they want. So could you replace me with a chatbot or an agent or conversation? Maybe. I don't think we're there yet. I think it's still too niche, right? I think that's not the perfect application. I think the Power BI thing, hey, I have a file, make a report, get me going, is an awesome application for that. Something I think you could also, potentially use it for is maybe inspiration. Right? I know it was actually on my to-do list. Something I'd like to do is take this sleep project, then just try to do it purely with AI. Right? And I get it to make stuff for me. Do I like what it looks like? But I use that as ideation, the way to get started. There's something like ChatGPT, right? You get basic charts. I don't think I would get. There's other systems that people in biz are trying to develop. to do other things like maybe infographics, style that. So I think there's tools you can explore for ideation. That's sort of another application. And certainly from like the coding perspective, also when you're beginning, when it's the language you don't know that well, you want to be, you want to remember the syntax for something. I think those interfaces are great. Observable notebooks and built AI into them, right? You can sort of use it in that function. So that makes a lot of sense as well. But I think for the super specialized, it's kind of more the space that I'm in. I don't think it'll replace what I'm doing. At least not in short term.
Thank you for such a nice presentation, Cydney. Basically, I would like to ask you, so into account different financial factors, did you consider to use any open source alternatives to the Power BI and Tableau, maybe Grafana or something else? And what do you think about such ideas? Because not all the time it is we can deliver something fast using JavaScript and D3.js, yes, because very often all these plots, yes, and interactive things, they should be calibrated and polished appropriately to deliver to your end client. So basically, my question is about Grafana, open source system, different open source platforms, and your thoughts about it and your practice in this field.
Yeah, so kind of using open source platforms instead of maybe something like AWS. So absolutely, I'm all for using open source systems. I think in the projects that I've worked on, those particular kinds of platforms, I used a lot. The client often kind of dictates the ecosystem. And like I mentioned earlier, sort of to my surprise, I'm actually doing more of the upstream design and less of the technical part, less of the choosing the stack and the actual implementation. So some of that has really been more on the client side to use what they've already established. But I think as a philosophy, I totally agree with you. I think there's a lot of power in those platforms and make a lot of sense to use. Certainly in academic environments, most of the things that we built, we made open source and shared code and very much sort of all of that. I think only really at Microsoft did I experience the opposite, where it's really much more, at least what I built is more focused. I hope that answers your question.
Hi, Cydney. My question is, what is your favorite and least favorite data visualization software library or tool and why? And what would you encourage people to learn? Thank you.
Oh, okay. So, wow. I mean, it really depends on what you want to do. But I have really enjoyed, to be totally honest, really enjoyed Observable. What I showed you tonight was built with like the lower level D3 parts of it. But man, the plot stuff that they've done, if you guys have used it, it's great. It's very, very intuitive and make something very quickly, something more standard. I even patched together different plots to make something a little bit non-standard, and was shocked at how quickly I made it. Like it's like, oh wow, that rarely happens. It's something's easier than so I really like Observable, and I haven't used their, what's it called, Observable framework to make more standalone things. I've experimented with that a little bit. So I would encourage people to use that. I think the D3 thing is a little bit mind-bending. It's a steep learning curve for sure. But the plot stuff, I think, is quite straightforward. It has a feeling of like Vega or Vega Light or something like if you use that, you can sort of declare, on this bar chart, here's your X, here's your Y. Um, yeah, the other part's harder. So what do I dislike? I mean, for the kind of stuff that I do, honestly, the, drag and click and sort of make a dashboard in something like a Power BI or Tableau often ends up just becoming frustrating. When you know how to make the thing at a lower level, you get really annoyed when there's like buttons in your way. Right. So they can be, they're incredibly powerful. They're amazing tools. They can enable so many people to make visualizations. I think the more time you've practiced, then you want to do other things that you can't do with it anymore. That's all. And I think it really depends on what you're using. At the end of the day, most important thing is that people use what you make. And so if they're using Power BI, you're going to make it in Power BI. It's going to be great, and they're going to use it, and you can make it bigger. So I don't really have like strong, deep held beliefs on one platform or another, to be honest. If I can make it work, and that end user's happy, and we've solved a problem, then I'm in.
Right answer.
And thank you for the talk today. I really like the part that you mentioned about what you do like on a daily basis. My question is, how do you usually test the data visualizations? I'm a product designer, and then I design like dashboard for the doctors and patient. I in healthcare tech industry, and I often find it difficult to test the visualization of data that's easy for like specific audience. So I'm wondering if there's any like tips you have to test the data visualization.
Yeah, that's a great question. I working at Microsoft was fascinating because there's, professional UR people, user research people, and they have a, deep methodology. So it was great to learn from them. I think applying it to biz, certainly, the kind of like talk out loud exercise can be really informative. So you have somebody sit down in front of your application, in front of your dashboard, just talk through what they're doing. And that can be super interesting to hear their thought process. And then particularly, find patterns across different people. Is everybody struggling with this one chart? And that kind of thing. There's certainly, when you don't have, on the absolute opposite extreme of that, there would be, telemetry data or usage data or something like that, which can definitely tell you part of the story, particularly if you're comparing different, reports, which report is getting high traffic. That can be informative, no doubt. But I think maybe what you're talking about is more that like with the user next to you. So I think the other way of doing it is, to ask them to complete a task. So something that we did. Can you achieve this particular thing? And then, after a short tutorial, see if they're able to succeed at that. That's also extremely important.